Welcome to Vessel Performance Optimization, a webinar brought to you by Digital Ship. Today's topic is how we can use algorithms on board the ship to help seafarers improve propulsion efficiency. We have two guest speakers here with us, Lars Stolstrup, CTO of Frugal Technologies, and Christian Larsen, Fleet Manager of Unitankers. This webinar is sponsored by Frugal Technologies. Please use the opportunity to ask the speakers questions via the Q&A box. And now, Carl Jeffrey, founding editor of Digital Ship, will introduce us to the topic.
Okay, thank you. So the topic is how to use algorithms on board the ship to help seafarers improve propulsion efficiency. We've got a technology we're going to present from Frugal Technologies in Aalborg, northern Denmark. And then we've got a interview with the fleet manager of Unitankers in Middelfart in central Denmark, which operate more than 40 oil and chemical and product tankers. So they can talk about how it works. So I'll try to explain propulsion efficiency very quickly. So the efficiency of the engine is not the same at all power levels. So you've got the energy that goes into the engine and the energy that goes into the engine, the power that comes out of the engine, the power that comes out of the propeller. And so for years, companies have drawn graphs to show how they relate, and you're more efficient at some speeds than others. So it sounds pretty complicated, but it's roughly the same as with the bicycle or a car. The car engines or your legs, if you're cycling, work best if you're going at a certain revolutions per minute. So, and then if the propeller has variable pitch, that's another factor. You can adjust the angles of the blades, and that sort of changes these curves. So it all gets very, very fiddly. Ship crew get given graphs they can use to work all this out. It's hard to use when they're navigating, and also the relationships all change as the hull gets more fouled. It needs more constant recalculating and drawing. So we could have a computer that does it all for them. So that's what we're going to present today. So we've got both a technological challenge and a human factors challenge. On the technology side, so the ship has a power handle. So that's the thing that goes up and down where the navigator says what level of power they want the engine to run at. So with this technology, we've got a box next to it. They can switch on when they want to, and that will optimize the power of the engine and the pitch of the propeller for the best fuel efficiency. And this computer box connects to the cloud. So there's some algorithms running there which can look at the data and continually update the curve because it changes quite slowly as the hull gets fouled. Now, the human factors side is perhaps a bigger challenge here because we're talking about something that overrides what the crew are doing about the RPM of the engine. So crew have got to have trust in it. And so this box, you can turn it on and off when the crew want to. So they probably won't want it when they're maneuvering in particular, but in the open sea, it can be most useful if they set the engine to run at a standard revs per minute, and the box will make small adjustments to the RPM for the most efficiency, and the crew can turn it off if they're not comfortable with it. So Unitankers save 12% of fuel costs using this. We've got another client, Royal Arctic Line, which saved 15%. So first, we're going to hear about the technology from Lars Stolstrup, who's the CTO of Frugal Technologies, who's got a background at route optimization at Maersk and has been working in AI and control systems and electronics. And then Lars from Unitankers is going to give a short interview with me and also going to take questions from the audience. So, and you can put in questions and answers at any time. So I'd like to invite Lars to give the opening talk. Thank you.
Well, thanks a lot, Carl. That's an amazing introduction. You got it right. That's great. It's as you say, this isn't exactly. It's complicated in certain parts, definitely, but we're trying to uncomplicate it as much as possible for the people on board. So that's very much what this product is about. Let me just share my screen so I can show you what we've got. Let's see now. If you go for this one, shouldn't be all bad. Yes. That looks about right. Good. So first off, Frugal Technologies, what's that about? Frugal, meaning as in saving money, being careful with what you've got. That is actually what we're about. We make best use of the equipment you already have on board. That's very much the point of the company. That's the products we try to make. That's what they're about. We're just a small company, and as Carl said, it's in the very north of Denmark. 5 people at this point, and a handful of vessels running our product, and to great success, we have to say at this point, and that makes us very, very happy. Which is also why we're here today with Unitankers, which is they've believed in us from almost the very beginning, and yeah, it's been quite the experience. But more on that as we go along. So, propulsion efficiency. What is that? It can be taken to mean quite a few things, but one of the things that I've always thought of, given my previous history at Maersk and all that sort of thing, is routing. Routing is very interesting to figure out how best to get from A to B, so you get the best cargo opportunities. You route by weather, currents, all that sort of thing. So you don't want to waste fuel by going too fast from A to B. You want to get there on time, not too late, all those things. That's definitely a very big chunk of optimization, to be good about the whole routing thing. But the other thing is the equipment efficiency. How to operate your engine and your propeller, if it's a controllable pitch propeller, which is mostly what we're about, the controllable pitch propellers. You have to make the best use of what you've got. And basically, that's what we want to talk to you about today. Making the best use of the components on board. Same as in your car, if you have 6 gears, you don't want to stay in second, you probably want to change gears a bit more. And you actually have similar opportunities on vessels with controllable pitch propellers. So why would you bother, you might ask? As Carl introduced, there is quite a bit of money to be saved here, because Unitankers saves approximately 12% fuel on the vessels that we've deployed Frugal Propulsion on so far, which is 2, with a third one being sort of in the works, and some more coming. And we have Royal Arctic Line operating container vessels in the very far north of the Atlantic, and they save around 15% fuel, which is very significant as well. Which is, and even 4 or 5% on top of the very best efforts that their engine manufacturers have been able to do. So that's we're pretty proud of that. And so basically what this means is that we are maximizing performance, even as environmental controls come into play, like the EEXI requirements, which are being finalized today, as far as I recall. Those requirements will basically mean that at some point, a lot of vessels will be capped fuel consumption-wise. They'll probably be forced to slow steam in some form or other, probably by capping the output of the engine. But within that power cap, you can still do a lot of optimizations, which will then mitigate at least the speed loss that you'll get from that. We can do that as well. That's pretty significant too. So how do we do that, you ask? It's quite the thing to say 12 or 15%. That's a lot. So it takes a bit of explanation to figure out why this can actually be true. So and even so, it's also quite interesting to talk about the return on investment. By the way, we have to talk about that. Most of our customers have a return on investment that's around, or maybe even less than a year. So also important. But how does it work? Well, first off, we have to consider the things that impact vessel efficiency. There are many things, but definitely the engine is a big one. Engines in your car or on a vessel have best performance points. In a car, that's basically one of the big reasons for having gears in the first place. That is, so you can keep the engine operating at a best sort of operation point. You change gears so that the engine remains at that point, even though you change speed. Same is true for vessel engines. They have best speeds and best operation points as well. These depend also on the age of the engine. It gets wear and tear. Linings need polishing and may not have been polished. There's fouling. There's the turbochargers. All sorts of components have varying performance at varying degrees of age and fouling. So there's a lot of variability in there. Then there's the hull, of course, because the performance of the hull makes a big difference as well, depending on fouling. Again, if you're dragging a lot of barnacles and whatnot along with you, that's going to cost some extra fuel. There's also the draft. How far have you pushed the vessel into the water? That makes a big difference, because the profile you're pushing along changes shape quite a bit, and that obviously costs a bit more fuel. There's the trim. How does the bow relate to the stern in the water? Is the relation between the two optimal or not? And then, of course, there are things like winds and waves and swells and currents that make a difference. We can't do much about those. That's a bit like going uphill in your car. You can't really do much about that, but that does cost more fuel. Same as downhill, that saves you a bit of fuel. But again, if the route is as it is, then that's just something you have to deal with. So we're not promising we can do anything about wind or waves here, but the things we can do something about is the combination of RPMs, the engine revolution, and the propeller pitch. And those two things together make up what we call the propeller curve, the progression of those two things. So in a bit more detail, we might want to talk about what does this propeller curve actually do. Well, on the bridge, you have the power handle. That's this guy up here in the corner. We're showing one from Neuss in Germany right here. And the thing about that is the captain or the navigator will want to push that power handle, and what he expects is sort of a smooth progression of power. If there's just push the power handle a little bit, he'll expect that he has a little bit of output power on the main shaft. If he pushes it all the way to the bottom, he expects to get full power ahead, and in between, a smooth progression. So that's what the captain expects. But that smooth progression comes from a combination of the engine RPMs and the propeller pitch. And as Carl introduced, the propeller pitch is basically how much if you were to imagine that the propeller was traveling through a sort of a solid medium, then the pitch is how far does it go through this medium per revolution. And you can vary this on a variable pitch propeller. So much like gears, you could combine a certain engine RPM with a certain gear or with a certain propeller pitch to get a particular speed. But it's significant which combination you choose. Same as if you drive in your car and you try to go 100 kilometers per hour in second gear, you're going to have a very high rate of revolution, and it wouldn't be very efficient. Whereas if you go in sixth gear or whatever, if you have that, it's going to be pretty good. And that's true for the combination of engine RPMs and pitch as well. One of these combinations will be the best to achieve a certain amount of speed. This surface you have down here actually shows a plot from an actual vessel of the engine RPMs, the propeller pitch, and on the z-axis you have the output power. So you can see sort of the surface indicates that there are several combinations that might give a certain amount of power, but one of them, again, is the cheapest fuel-wise. So that's one thing to consider. You definitely have to get the correct combination of RPMs and pitch to be efficient. But then there's the engine itself. It doesn't accept all sorts of operation. Same as with your car. You can't really start your car in fifth gear. That wouldn't work. You can't drive your car in first gear all the way around. That's not going to work. Some points of operation are just not safe, and some are just not efficient. This bit over here is actually a snip from a manual from a Wärtsilä engine, which shows the area of operation that the engine sort of accepts. There's this notion that you can drive the engine at a certain amount of RPMs, and you can force a certain output power from the engine, which is basically what you get as you increase the pitch of the propeller. You force the engine to do more work, and that's all good and fine. If the engine is clean and everything is good, then you can expect things to operate as you see here. The black line here, the one that I'm pointing at right now, I guess you can see that. I hope you can see that at least. Indicates the sort of maximum load you should add to the engine at a particular speed. So that's good. Okay, so assuming that the engine is clean and everything is well, we can do that. But if the engine isn't clean, or let's say maybe the propeller hasn't been polished, then each time you spin the propeller, you're also dragging barnacles and the whole thing around with it, and you're actually adding more load than you expect to the engine, which then pushes the engine into the gray area, which is, no, we don't want to be there. That's just for temporary operation, or you could even be pushing the engine further out. So in practice, what you do is you add a certain buffer to the maximum load that you can that the engine accepts. This is the green area. So you actually create an artificial sort of running margin, which is there to ensure that whatever you do and however the engine operates and however old it is and however fouled your components are, the engine won't suffer. It's going to be okay. So the blue area is then the area that will be considered safe at all times for propeller curve operation. So even though everything is fouled and things are not nice, propeller curve is fine. But there is a few things about that that might not be what you want, because let's say that the engine is entirely clean and very nice, then you don't need that green area. You could actually move the blue area all the way out to the maximal load curve, maybe, or at least somewhat closer. And the thing about that is, as you add more load to the engine at a particular set of RPMs, let's say 900 RPMs, typically that's more efficient. You actually get more work done for the same amount of fuel. So you want that if you can. So what do people usually do? Well, propeller curves is not a new thing. So most vessels that have, well, all vessels, I guess, that have controllable pitch propellers also have propeller curves installed from the factory. But these propeller curves have to take engine efficiency at all ages and all conditions into account. So even though the propeller curve would be or could be better from the get-go as components are new, then you also have to take into account that what will things be like in 10 years? What should it look then to be safe? And these curves I'm showing here are just a couple of examples, more or less real world examples, where one is simply a naive curve, the orange one here, that in some instances they're just plotted like a straight line, so you don't really have you haven't really taken much of the propeller or engine efficiency into account. You just plot a straight line and that's your propeller curve. That's pretty wasteful, particularly at lower speeds. You see that there's a lot of room between you two. You could add a lot more work to the engine without getting into trouble. And then you have the optimized curves, which is what you get with most propulsion control system, which has been optimized from the factory, but taking into account that things won't look equally good at all times. So it's a good curve, but it might not be equally good at all times. Well, certainly it could be made better. So one way to go about it, to make things better, is to have a look at what does the engine actually do? Is there a way to monitor what this green area, the running margin, should be, rather than just assume that it has to be at a certain size? As it turns out, there is. We can actually have a look at the engine temperatures and turbocharger pressures, for instance, to see how the engine is performing and what's the engine health at a particular set of RPMs. And the graphs we're showing here are actually from a vessel that we've been working on for a long time, which has a bit of a strange setup. And it starts out in the orange graph here, which shows that even as RPMs increase from 150 or so to 160 or so, we can add almost no load. And this turns out to be because the turbocharger was pretty fouled on that particular vessel. A few other things needed to be changed as well, but definitely as things were then cleaned and the vessel had been docked, you can see that the maximum load curve changes quite a bit. And the distance between the blue and the orange curve is actually the bit of it corresponds to the green area on the graph we saw before. So this is the added operational area you get from cleaning things up. Obviously, if they were using a static propeller curve, they would always have had to be within the orange sort of load curve, because otherwise they wouldn't have been safe, even if the engine was fouled. So if we look at another strange parameter another parameter that may seem strange to some, then that's the vessel draft. Because what happens if you push the vessel further into the water? Well, as we talked about just previously, definitely the shape that you're pushing through the water changes, and that makes a difference. You have to do more work to push it through the water. But there's also another thing going on. This is actually a plot of, this is the same vessel again, actually, a plot of RPM versus pitch versus propulsion power at high draft. That is when the vessel has been pushed solidly into the water. And you get sort of a nice smooth surface with, it's pretty much as you would expect. If you add more RPMs and more pitch, well, then you get more power. But then at low draft, you get this interesting looking surface, which says something quite different. It says that if you're running at certain RPMs, then that's not great at all, because the power drops off dramatically for some reason. Why might that be? Well, I had the chance to actually look at it physically, and it turns out that this is, and those of you who've been on vessels, I will also know that this is true, that if you look at the wake of the vessel, then sometimes at certain speeds, you'll see that the wake of the vessel, that is the waves that the vessel generates when it's sailing along, will sometimes coincide with the area that the propeller is operating in. So that means that the water level is actually lower at the propeller than it is around the rest of the vessel, which means that the propeller may be quite close to the surface, and then it's mainly just blowing bubbles and making foam and all that instead of actually pushing the vessel along. And that's what's going on here. So obviously, the same propeller curve will not be good for high draft as it will for low draft. So if we put all that together, we get to something quite interesting. At least I think it's interesting. I hope you do too. Which is that if we look at the comparison between a static propeller curve and the one that's running at the adverse conditions and at the good conditions, which is the orange one here, you see that the distance between them is quite great, and that this corresponds to additional work that the engine could have been doing at a particular set of RPMs, which again corresponds to more work per fuel unit you actually pump into the engine. So you get more speed at basically the same fuel cost, which is quite the deal. So, well, what are we doing about that then? How do you put all this together? Well, that is what Frugal Propulsion is actually all about, because we do the exact combination of these things. We actually generate the propeller curves that take into account vessel draft and the engine conditions, and actually a few other parameters that we won't have time to talk about today, because it's like trim and dynamic trim and things like that. Subject for a different talk, maybe. So there's the proven significant savings on the fuel consumption. That's one thing. And then there's the significantly reduced CO2 emissions, because those two sort of follow along with each other. If you spend 1 ton of fuel, well, then you're going to emit about 3.3 tons of carbon dioxide. And that's directly, those two directly correspond to each other. So that's a significant savings on that account as well. And the other thing we do is that all the data we collect on the vessels also goes back to you. If you want it, it's open access for you. You can get your data, and you can use the same data that we use to validate our results and to do whatever else you need to do to figure out what you need to figure out about performance on your vessels. So what about the physical components? What is it you actually get? Well, it's pretty simple. We mainly show up with 3 things when somebody buys our product. One is this display unit that you get on the bridge, which is pretty much the same as an additional power handle. So the captain would usually use a classical power handle. He'd push on it, and here he has an up and down button instead of a push handle. But it does the same thing. If you push up, you get more power. If you push down, you get less power. And it takes part in the control system, much like a joystick solution or something like that. So you have to request control to have our system take over. But that again also means that if you want to just sail along as you've done previously, well, then you can just not use our system, and you'll be back to using your regular power handle as if nothing had changed at all. Of course, you won't be saving any fuel, but then there's that. So our system is an on-top system. It doesn't replace any of the existing control mechanisms. It doesn't replace any of the safety mechanisms, but it does add some safety mechanisms when our system is in control. And the thing you get, of course, is that you always get to run your vessel at the latest available propeller curve, because the thing is, we collect data continuously about the vessel, and that data is also continuously validated against the previous set of data we have to make better propeller curves, if possible. And then those are deployed to the vessel. So it keeps optimizing all the time, feeds off the data we collect, feeds off what we know from the propeller curves we've already had deployed, and it feeds off the performance measurements that we can do all the time. On top of that, we also have cruise control integrated in our system, so you can keep a constant speed. Or if you have a tanker vessel or some other vessel that's chartered to be running at a particular consumption level, we can also guarantee that you stay at a constant consumption level. And all this while maintaining the safe operation of your components. That's still core to what we do. The other thing you get is the electronics cabinet. This is maybe not quite so exciting, but it does show that this is sort of the integration point. This usually lives somewhere in the ECR or close to it. And this has the integration with the existing engine controls, propeller controls as well. It also serves as the integration point for sensors like torque sensors, fuel flow meters, GPS, speed log, all those things that we want to collect data on. Those also end up in here. It also serves as the back end for the panel on the bridge. And any other displays we might supply. We also have additional displays if you want some for just data viewing. And then it serves as integration point with the cloud engine, which is actually where most of the exciting stuff is going on. So what's that all about? Well, the cloud engine is not exactly something that we supply in the package, but it's a component that runs on a service center in Germany, and this is where all the data we collect from the vessel ends up. And first thing that happens when the data ends up in the cloud component is that it gets integrated into the data collection. And then we start validating the data also, because that's one of the opportunities you get by doing what we do, is that we can actually check up on the sensor data, that it makes sense before we start calculating any new propeller curves from it. But once we're happy that the sensor data makes sense, we then calculate what the optimal propeller curve would look like for the particular vessel at this particular time, at this particular condition. And if it's different from the one already out there, well, then we deploy a new propeller curve to the vessel. This doesn't happen every day or every hour or anything like that. It happens when something significant changes, like the vessel has been loaded or unloaded maybe, or fouling has changed performance characteristics, things like that. So this is not a constant adjustment. This is something that happens when necessary. The other thing you also get from the cloud component is access to your data, both raw data and via this very nice web component that we've developed and are still developing, which will contain whatever metrics we can dig out of the data and whatever else we come up with along the way. This includes, we won't promise you anything about when, but this will also include predictive maintenance somewhere along the way. Did I remember to say everything I wanted to say here? I think I actually did. That's pretty good. So I've been talking a lot about how we think this system is the greatest ever, but you shouldn't believe me and you shouldn't take my words just at face value. You should probably talk to one of our customers, and to that end we have simply been so super happy to be on board with Unitankers, and we really cannot appreciate their support enough. I mean, we're a new company and things have been progressing quite rapidly in many ways, and they've been very supportive in testing our stuff and making sure that we don't that the data we actually collect and the results that we believe we've collected are actually true. They have been very good about that, and you'll have the opportunity to hear what they think about the experience as well, because I think Christian would be very, very happy to talk to Carl about that now.
Oh, well, thank you very much. So now we have Christian Larsen, who's the fleet manager of Unitankers, which operates more than 40 oil and chemical product tankers. So maybe if we start with the storage, do you want to talk about so why you chose this and a little bit how you're using it so far?
Yeah, but it's obviously why we chose it. Today, if we can save any fuel, then that's very welcome. We get a saving. It's and of course the green profile, CO2 reductions is also in time. So yeah, any saving we can do in that regards right now is very welcome. And you can say this Frugal system is very easy to implement. We don't basically have to add any major things or set up any new systems. We've just installed a few flow meters and a torsion meter, and that's basically it. Run some cables and then it's running. So yeah, it was a no-brainer. So
yeah. I mean, lots of the other shipping companies we talk to go to a slightly different approach with this performance monitoring center and central control. I don't know if you're doing that as well, or you thought, well, let's just give support to the crew. That's the most important thing. So we'll start there, is it?
Yeah, I would say we took the decision in the office to do it. But then, of course, during the installation, we had Lars on board and the other Frugal guys, and then they gave the crew and captains a good briefing how to use the system and so on. Of course, it's a little hurdle because we are used to running fixed RPMs using the shaft generator like everybody does and have done always. So it is a challenge to convince people that this is the new norm. And in the start, they don't believe it because it should be efficient, most efficient to run the shaft generator at fixed RPMs on the engine. But then when they actually see the results, then they start, okay, yeah, data don't lie. So, but indeed, in the start, they're not convinced about it, but they do it and follow the instructions. We run in the system, Lars optimize the propeller curves and so on. And then, yeah, they can see a saving and then they buy in on it. So,
are you talking about the crew now or your office staff, or both?
No, the crew. We I wouldn't say we ate it from the first moment, but of course we could see when we started installing, they already done 1 or 2 test vessels, so we could see there was some data, and data don't lie. And Frugal gave us a very good offer with a guaranteed saving. So yeah.
Well, so, and the data's or the fuel consumption for a given voyage or something. You said you used this many tons last time. Now look how many tons we're using now. Is it? That's how you?
Yeah, you can say that.
That's a very simple way to show people how this. I mean, this is the hardest part of it, like you're saying, is convincing people to.
Yeah, and you can say, for example, the last vessel we just installed one was Fenris One. It came out of dock in Turkey here. Was it 8th of May? I think we did the sea trial, and then the vessel test in different conditions so we can compare. Lars can do some optimization, and the crew can see when they enter all the data when they send home that it is working. So yeah.
Oh, and do you have an office overview as well, that where you monitor it yourselves, or is that something you have as well?
We use the solution where we log in online and see the vessels running, and then we have Lars, and we also have one intelligence in the office, and he also collects the data and calculates and so on. But yeah, and then we can see the direct saving. So.
Oh. And what's your bigger drivers? I mean, is you doing this just because it's good to be green, or you've got banks like some people do finance deals with the ships where they promise emissions reductions and things like that? Is that something you're able to talk about?
Yeah, I would say it's a combination. You can also say our fleet is the small oil chemical tanker fleets are getting older. So we were also interested where we could do some investment where we can see a quite fast return of investment without changing a lot of components on the engine. And this required free flow meters and a torsiometer, which we are installing anyway on the vessels. So yeah, so we're quite dependent that it's a fast return of investment. Because for example, Fenno, when you do a docking on a 12.5 years old vessel, we're not interested in investing millions, you can say.
Yeah.
So
the charter normally pays for the fuel. Don't they? Or maybe under your contracts you pay for the fuel. Do you?
It depends on the contract and the voyages. Normally we on the spot market, then our vessels are just fixed for. We get so much money to transport the cargo from A to B, and of course there's some time frames for that contract, but otherwise we more or less set the speed. As long as we arrive within lake hands and everything, then. So the saving goes directly into our pockets, you can say. So.
Yeah, very good. And do you want to say anything about the actual installation? How many ships you've done it on, or so far, or what you're planning to do it for the whole fleet, or anything like that?
We've done it on our vessel in Delo last summer, and then we just did it on Fenris One and Aries One, and then we have, let's see, 2 more vessels for docking coming up. We're going to install, and then we are having plans with Frugal for 2 more sister vessels for the Aries One also. So basically we're running it out whenever we can.
Oh right, yeah, because there's 20 vessels you're operating, but you said you don't own them all, or some of them are chartered in or something, aren't they? Or somebody else actually runs them technically, is it?
Yeah, we own and run 17 vessels technically.
Okay.
So,
Okay. So you probably have it on all 17. I don't know if that's a question you're able to answer, or we'll see how it goes. I guess maybe it's.
I don't know if we'll do it on all. Also depends on trade. We have some that
Right.
runs small voyages fixed as bunker traders and so on. So that won't. But all the ones that's in the spot market also, yeah, considering if we're keeping them for the next years, then we're going to install. So.
Oh, well, that's fantastic. Well, so it sounds like it all works, and it wasn't that easy, but it's definitely worth doing, and it's giving its own momentum now that it's working. Yeah.
I wouldn't say it's difficult. I mean, it's we usually do it when we dock in. So we install 2 fuel flow meters on the auxiliary lines in and out, and one for the main engine. We replace it because we need some extra data and so on out. And then we install a torsiometer, which we already planned. So we're using these Laymark, and I think the investment is 10,000 euros for a torsiometer. And then we run a lot of cables, of course, but basically 3 cat cables from engine control room to the bridge, and then a little bit inside the control room, a little bit out in the engine room. It's nothing major, and yeah, then Frugal is able to set up their system and control box, and yeah. So.
Oh, it sounds great. Well, we got a couple of questions. The one I don't fully understand, but the first one, maybe this for yours. So Diane Murakov is asking about cloud cybersecurity. I think you're just sending propulsion data, so it's not like people are controlling the engine via this thing. Your analysis is just improving the curve. Do you want to answer about the cybersecurity?
Sure. Yeah, that's a very good question. Thank you for that. It is very important to keep that under consideration, but we're using actually my previous career was in banking, so I'm a bit environmentally damaged from that, I guess. Anyway, so we're using two-way encryption and certification to ensure that we know exactly both ends of the communication when we're communicating with the vessel. But the important thing, as you say, Carl, is that we're not actually controlling the vessel remotely. That's not possible. The only thing we can do is push data one way, which is the sensor data from the vessel, and the other way we can push a new propeller curve. That's it. Nothing else can happen on that channel. So in that sense, it's as safe as can be. But again, being from the banking world, you can't say 100% about things. But then if you control what you send, then the safety increases as well. Because definitely, if it were possible to do anything control-wise rather remote link, that wouldn't be good. But you can't. So there's that.
Wow, okay. And there's a question from Alexei Fititskin in Latvia, which I don't actually understand, but maybe you know. I've asked him to clarify, but he says, are there any requirements for the vessel to get control for engines? Does that?
Well, maybe he's talking about the integration, the actual integration with the engine components, because yes, there is, because as I've talked about a bit just previously, our system is sort of an on-top system, so we don't replace any of the existing control electronics, but we build on top of it. But that also means that we need to have some sort of an interface between us and, say, maybe Alphatronic if it's a man system, or Noise if it's one of the systems from Noise. So there is a small adaptation needed to the existing control electronics, and that has to go into the project as well. We've done that with Unitankers as well, and it's usually we have good cooperation with Kongsberg and MAN, and you have Noise and Berg Propulsion and others as well. So it's not much of a problem, but true, yes, that does need to be an integration.
Okay, so Eric Hofmeister is the head of vessel management with Samskip, which has 6 container vessels, 4 reefers, 10 chartered in feeders. He's asking, do you have to work together with the engine makers? So he's saying, perhaps if you reduce the RPM, there's going to be a bigger load on the bearings, and have you involved class?
Also an amazingly good question. Well, it's true that if you do reduce the engine RPMs, you will change the sort of the load profile. But again, we always stay within the operational characteristic given by the engine manufacturer. So we stay safe in that way. We don't change it beyond that. And usually, even more on top of that, the amount of reduction we see in RPMs is usually, well, actually never beyond 20% reduction. So we don't go to, let's say, half speed for the engine at any time ever. 20% reduction is like the maximum we see. and again within the operational specifications of the engine, so we stay safe.
Oh, okay. So if we go to the top question, it's kind of semi-anonymous question, which I don't really like, but, but he's asking about how high frequency data like auto log data. Maybe if we go to Christian, so you said you installed the flow meters, which is high frequency data, but the updating of the propeller curves only needs to happen once every couple of months, as I understand it. Is that a, so I guess you're jumping from this high frequency to low frequencies.
Was that for Christian or me?
I don't know, maybe Christian, but if you'd like to.
Yeah, sure.
No, the analysis doesn't require basically anything than what Frugal can pull out of the system. Obviously, it's connected to via our VSAT system, so Lars gets fed all the data he needs live, and then he does the analysis, and then he uploads the new improved curves and so on. So it doesn't require any manual input from the crew as such.
And I think I get maybe the point is also that we don't. It's actually important point is also that we don't require a constant connection to the vessel, because there was something about high frequency. Yeah, the data we collect is actually not that high frequency. We do collect data every 5 seconds on board the vessel, but the onboard system actually do basic statistics and compress the data, so we only get to sort of 1 minute samples, and that's the stuff we send home. But it doesn't really matter if the connection is down for a day or 2 or even 5. The data just gets queued up on board and then sent home whenever the connection is available, and then optimization happens after that. Obviously, if the connection isn't up, then you can't have any new propeller curves, but then you'll just be working on the one you already have, and that's probably going to be fine as well. So the data frequency is quite low, the bandwidth requirements are low, and the connection quality doesn't have to be all that good. So we can work on most setups. Okay,
so Sanjay Relan is the General Manager of Voyage Optimization at Pacific Basin Shipping Limited in Hong Kong. So we're interrupting your dinner, Sanjay. Thanks for thanks for joining us with a question about fixed pitch propellers. I don't know, Christian, what you're talking about, your vessels will have controllable pitch propellers. So the 12%
all our vessels, have a CPP, yeah.
Do either of you have any thoughts on
our product doesn't really, we don't have much in the way of help for fixed pitch propellers, unfortunately, because the thing about those is mainly you can spin them faster or slower, and that's about it. Whereas with the controllable pitch, you also have the option to tilt the propeller more or less, and then you get the nice combinations you can get out of that. But the fixed pitch propellers, well, we're working on something, but at this point we don't have anything for fixed pitch propellers.
I suppose the vessel's normally much bigger, so any savings are worth much more, I suppose.
That's true, and that's definitely also why we're looking into it. But obviously you can't do much about the propeller, so there's that. But we are looking into it, because definitely you could do something for the with respect to crew support. You can still do the cruise control. You can still do the constant power. You can still do a combination of those to make sure that you meet charter requirements and all that sort of thing. And there can be quite a bit of savings in that. But equipment-wise, we haven't really got anything much for the fixed pitch at this point. But not to say that we won't have. But mainly we concentrate on the ones with the controllable pitch for now.
Oh, okay. So Hiro Yoshida is asking, how easy is it to fit on board existing ships, and how many days it took? And I guess also, can it be done during the voyage? Is that for Christian to answer, maybe, do you think?
Yeah.
I would say, yes, you could install it in operation. It would require some stops. We have more or less chosen to do it in the dock because of the cabling. Most of our vessels are built in Turkey, so the cableways in the vessel is not straightforward. So it requires some cabling. Normally we get the yards to do it. We make a plan with Frugal and check where we can run all the cables down through from the bridge to the control room and so on. And then it's basically a question how fast the yard we hire into to do the cabling, they can do it. The first vessel in Delo we did while alongside a Danish shipyard. I think it took, while we're alongside, totally 8 days, and I think the cabling took around 4 or 5 days total, with termination and everything, closing up again. And then The torsiometer, that's no problem. We have smaller vessels with limited space, but we've chosen Lemac type where they have some designs for very narrow space and small axles and so on. And then the flow meters, yeah, it's just to install them in an outlet for auxiliary. And then we have the down on our fuel conditioning units for main engine, then we simply replace the flow meter already there. So it requires a little bit maybe of piping modification to be done. It takes 1 day maximum. So I wouldn't say it's super easy, but as long as you get your plan for how to run the cables, then it's pretty much straightforward.
Yeah, we did a webinar with a company ScanReach that does radio communications protocols designed just for ships a few weeks ago. So maybe that's something to
maybe for the future.
Yeah.
Like I could just add to that as well, because I think the fastest installation we've done was a vessel which actually already had the cabling in place. So that is true, as Christian says. That is kind of the hurdle. That there can be quite a bit of work involved in getting cabling done, but this particular one actually had the cabling in place, and then it was 2 days alongside, not in docks, just alongside, and actually only just 1 day when we need to establish the interface between the existing engine electronics. We need to take things offline, so we need basically 1 day for the ship to be completely offline, and then that's it. But then 2 days, that's the fastest one we've done so far.
Okay, so Eric Hofmeister of Sam Skip is asking, are we getting any sort of, I hate this word intelligence, but can it say you've got a fouled turbocharger, give specifics about what's going on? I guess you can tell if the curve is changing, which is the most useful thing to know, isn't it?
That is an amazingly good question. And yes, that is some of the stuff we're working on just now, because we have the data and most importantly, the correlation between data. Because if, for instance, if you have the engine load and you have the output power on the shaft and you have engine temperatures and things like that, then you can easily correlate them and say, well, if the temperature is off and the power is on, then something is getting fouled. Or let's say if the power is off and the load is high, well, then something else is going on. So we can actually pretty much pinpoint which bits are not performing as they should. And that's going into the sort of the predictive maintenance components that we're building now, but not done building. They're coming.
Okay, so Anna Shrivastava, I've been looking up speakers on LinkedIn. He may be the team lead marine superintendent at Chevron, but there's a few people who came up. But he's asking about AI, which learns from previous experiences. So we decided not to use the word AI for the title of this, because it's such a, well, I find it a horrible term, but I guess
that's true.
We originally were going to use AI, but do you want to elaborate on that?
Yes, because it is a learning algorithm. Our service center components are running learning algorithms, but because basically we're using Bayesian statistics, if we're going into details, which is a sort of a learning model wherein we take the data that we get from the ship, we parse it, and we get sort of an idea about what should happen if we change parameter so and so, and then we monitor what actually happens when parameter so and so changes, and then we update the model, and then we are able to predict where we should push performance to get a better propeller curve. So yes, it is a learning algorithm. You might call it artificial intelligence, but then almost everything is called artificial intelligence these days. So there's that, but definitely a learning algorithm, that's for sure.
Oh, and so you're sending all the data that the ship is gathering to your central place, and then
yes.
You've got sort of data scientists, or maybe you're doing it yourself, trying to improve these curves based on what you see. Is it?
Yeah, well, our algorithms, well, first off, to begin with, at the very beginning, we actually did it manually to figure out, well, what actually goes into making it better. But and as we understand more, we code it and turn it into an algorithm that does the same thing, basically. So the optimization goes from something that happens in our heads to something that happens in the service center. And then on top of that, the validation to make sure that we don't base propeller curves on bad data, for instance. That's an obvious pitfall that you can do. So that's very important if you do things like that. You have to have the model, and then you have to have your validation so that you can pair the two things and make sure you don't run off sort of the edge somewhere. Yeah.
So Diane Mravkov is asking about hybrid propulsion or electrical driven propulsion. I guess I don't think you are working on that, but
well, we're not working on it, but definitely Alternative fuels and hybrid propulsion systems could also be relevant to. I mean, the optimizations are still sort of the same. You can still have a propeller curve that's better or worse, and that makes it a difference to the amount of power you use in any case, whatever the power is, if it's electrical or diesel or ammonia or whatever it becomes these days. You can still save on it. So yeah, it will work in that respect as well. We don't do anything in particular for diesel electrics, because again, it's power that goes into the water, and you can do it efficiently or less efficiently, and we can help in that respect, definitely. Yeah.
Oh, very good. Well, I've got a question myself for Christian. I mean, just sort of building on why you chose it. I mean, so there's a lot of fleet managers in your position around the world who've got these enormous challenges and pressures to decarbonize, and they get seeing all these technologies and how on earth do I make decisions, and so anything more you can share about your kind of thought process. I mean, like we were talking about before we started, this goes onto the ship, so this is where fuel performance happens. It happens on the ship, so support for the ship is maybe a more useful way. And it's great that you've got this kind of, what people call it, this closed loop you put in the system, and you saw the results, which is something not many companies can say. A lot of companies have invested in massive systems for gathering data and reporting, but actually showing something at the end of it is proving very hard. So any more you can share on this question, I think is very interesting for the audience.
Yeah, you can see the obvious. Yeah, we have a saving and we have a good return of investment. Of course, the CO2 reduction we have instantly. We are also doing all this CSR reporting and footprints and all that. The green profile, that's also very important for customers nowadays. It's increasingly demanding. Then of course we had the crew with us, and they can see the benefit from the systems. But what also appeals to us in this is that we don't have to do anything. I mean, everybody's talking about big data and yeah, but we don't have to look at it. I mean, we use our time better supporting the vessel, doing all the technical issues. You can see all this, we talked about this AI optimizing. It's automatically uploaded onto the systems, improved. So we can see a saving, and then basically we don't have to do anything. We get warnings if something is wrong. We can see how much we save, because yeah, we wouldn't have time to sit and analyze on all the vessels, on all the savings. I mean, we get more or less. We already have overload of data in the every day. So the more simple and not complicated, the better for us. So yeah.
Well, there's words that the shipping industry loves to hear. The more simple, the better for us. The less data we have to deal with, the better with us. Yeah, that's anything that reduces the data is good news, I think, for shipping industry.
Yes, that's very good news. So.
Yeah, okay, but we're going to get into a complicated issue now with this last question on shaft generators. I think go back to you, Lars. So we were talking about we started. So maybe yeah, how does a shaft generator fit into this whole map?
Yeah, I can then, I don't know if we're supposed to, but I can share that we actually have plans of phase 2 of this Frugal system. And that means we're looking at installing frequency drives. And that means we will be able to run the shaft generators at variable RPMs. So when we're running in combinator mode. So yeah, so that's the next plan we're working on with Frugal now. We're looking for the correct frequency drives. And then on the first vessel in Delo, we installed the Frugal system. We have already prepared with a breaker on the main switchboard and so on. So we have the foundation laid. So we all more or less only need to install it and lay the cables. So that's the next plan actually. So we can do with the shaft generator while running combinator, and then we of course save the fuel for the auxiliary engine. So
and the service.
Yeah. Maintenance, running hours. Yeah. So.
Okay, you need a computer to work all this out for you. What's the right choice, isn't it?
Yeah. So that's phase 2 we're working on now. So.
It's quite interesting with the to begin with. I guess people have been designing vessels around having a shaft generator, and then accepting that you would have to run the engine at constant speed to make use of that shaft generator. that and obviously that saves you from at least some amount of fuel on the auxiliary generators, because even though the shaft generator is more efficient just running off the main engine, it's not like it's free. You don't get the power for free. You still have to burn fuel to get your power, but it's better than using the auxiliary engines. But the main thing is for at least for many is that you reduce the running hours and the service costs on the auxiliary engine. So that's a big thing. But then, as Christian says, you have to consider getting a very variable frequency drive to compensate if you want to get the best of both worlds. So we don't supply those, but we do work closely with the manufacturers and vendors that actually do supply these things. So we can help out when it comes to making that happen as well.
I don't know how big an investment a variable frequency drive is. So just to explain, so the shaft generator needs a standard RPM because it's generating power. Otherwise, if it doesn't, the frequency changes of the AC.
Yeah, exactly. Yeah,
so
that's the thing.
For that, right? Yeah.
Exactly. So it varies quite a bit with the size of the frequency drive that you need. So it depends very much on the amount of power that is consumed on the vessel. They can go for, but it's a significant chunk of money that you have to put into it. I guess, Christian, do you have some numbers on the Indelo vessel, maybe?
I can say that our calculations for the return of investment, including phase 2, would be 2.5 years.
Okay, so that's still pretty good. Yeah,
so that's pretty good. So, but it's the variable frequency dive. That's the big chunk that comes. So.
Yeah, it's definitely a bigger chunk than the frugal propulsion chunk. But again, depending on the vessel. On some vessels, the amount of power you use is maybe on like coasters or bulk carriers, things like that. The amount of power you actually use is quite small, so the frequency drive will be a comparatively small investment. Maybe I don't want to sling around any numbers just now, but because I don't have them offhand, I'm afraid. But definitely, we've seen some cases where it doesn't add that much to the entire project.
I can also say that our return of investment is based on right now 210 sea days, which is not so much. We have with our small chemical tankers a lot of anchorage time and waiting time. So of course, if you can increase the sea days, then you'll have a much better return of investment.
Yeah, we have that, for instance, with the Royal Arctic line. They have a return on investment, even including the frequency drive, as I recall it, of just a little bit more than 1 year. So there's that.
Okay, so Hiro Yoshida is a executive managing director of BMAC Corporation in the Netherlands, but I don't know what FOC data is. Do you know how much frequency does Unitankers get FOC data usually and instruct order to ship? Do you understand that question?
I don't understand it in connection with the frequency.
FOC data. May have to elaborate
a little bit.
Oh. Yeah. I suppose this frequency data is kind of a complicated question that often comes up, isn't it? Because I guess a lot of shipping companies are struggling to get lots of data from the ship, and we're saying here that we don't necessarily need to. I suppose we don't need to have continuous streams of data from ships to improve vessel performance, which is quite an interesting.
It's interesting it's been a point for us at least to make a solution that sort of feeds off its own data, so we don't have to inject sort of a set of people that need to sort of eyeball data to get something out of it. It's a closed loop that feeds off data, makes performance improvement, and goes on like that. So and you can look at the data if you want, of course, but you don't have to.
Google tells me I think it's fuel oil consumption data. So yeah, that's the flow meter data.
Oh, okay. Well, we definitely send that back home as well. Yeah, at same frequency as everything else, so you get it at 1 minute resolution, and we can change that to something less if that's what you want.
Yeah, you don't need it 1 minute. You could have it 1 week by the sound of it.
Oh yeah, sure, you could do that as well. But I mean, if someone was interested in looking at the actual here and now data, then our resolution is we get a data point every minute. But you could also change that to less if you want, or more. That's up to you, more or less.
Yeah. Also, just to sum up, we can just tell that what Frugal collects is they collect, of course, the data from our fuel oil flow meters, all three. You connect into the Norris or Alphatronic systems also for all the data there, so you can say everything is gathered, all that's needed, also the fuel consumption and so on. So yeah.
Oh, that's fantastic. Well, we're coming up at the end of the hour now, and the thing that's going to stay in my mind is Christian saying less complexity, less data. It's all good news, and we'll pass back to Vida. Cheers. Thank you.
Thank you. So you've just heard Lars Staustrup presenting Frugal technology designed to improve propulsion efficiency and the use case of Unitankers together with Christian Larsen. An update about next Tuesday, we invite you to join a discussion on shipboard cybersecurity. You may register on our website or simply follow updates on our LinkedIn page. Digital Ship is signing off. Take care. Until next week. Bye.
Bye. Oh.